We are finishing up chapter 7 talking about a very important concept related to scatter plots, and that is correlation. So let's look at a definition first. Correlation is a number that measures the direction and strength of a linear association between two quantitative variables. This is now a specific number that's going to be able to tell us those two things. Now there is one important thing that I want to highlight. It only tells you the direction and strength of let's do that in a different color, of a linear association. If you make a scatter plot and you do not have a linear scatter plot, you cannot apply the concept of correlation. So there are conditions for using this. One, you must have two quantitative variables. If for some reason you have a categorical variable, you cannot apply correlation. Is the scatter plot straight enough? Okay, the scatter plot has to be straight. Yes, that's a judgment call you make. If it looks straight, it's fine. If you see an obvious curve, then you don't use correlation. But if you don't see an obvious curve, then you can assume it's straight enough. And outliers can distort how strong your correlation is. So if you look at a graph and you know there's an outlier that is completely away from everything else, you can leave that off when you're putting stuff in the calculator to calculate correlation. Now there are some correlation properties. Because correlation is a number, the sign of that correlation number gives the direction of the association. So if the number is positive, that means that the direction is positive. If the correlation value is negative, that means that the direction is negative. Correlation will always be a number between -1 and +1. -1 and +1 are considered perfect. Correlation can come out to exactly -1 or +1, but that is very, very unusual because that would mean that the data points fall exactly in a perfect straight line. And in reality, the chances of that are not very good. Correlation near 0 corresponds to a weak correlation. So close to 0 is weak, close to 1 or close to -1 is good. And I'm sure you're thinking, well, what about everything in between? So I have a little breakdown to make life easier. If your correlation number is between 0.75 and 1, you can say that it's strong. If it's between 0.5 and 0.74, you can say that it's moderate. And anything below 0.5 goes into the weak area. So hopefully that'll give you a pretty good idea. So let's look at an example. So here are 4 scatter plots, and we have 4 correlations calculated. We want to know which one is which. Well, hopefully you're looking right away and you're thinking that A is going to be a problem. I'll put a little star here. He's a problem because he's not linear. So let's do the linear ones first, and then we decide after that what's left. So which one of these looks like the strongest one? Well, I'm thinking that's C. Well, what direction is C going? It's going down. So we have 2 negative numbers, -0.923 and -0.487. Now this is strong, this graph is, or it's stronger. The closer you are to +1 or the closer you are to -1, the better. This one would be the -0.923 because that's really close to -1, and this is a pretty good line. Let's look at B. B is a little more spread out, not much, but it's a little more. Is it positive or is it negative? Well, it's positive, so that would leave us with the 0.006 and the 0.777. Well, it's still pretty good, so obviously it's got to be closer to 1, so this is your 0.777. Well, D, it's not curved, but it doesn't look the greatest. But the big question is it going positive or negative? This is going downward. So the only negative one that's left that we haven't used is the negative 0.487. Remember we said anything below 0.5 is weak. So this is weak. That leaves us with A. Well, the reason A doesn't belong is because it's not linear. If you were to put this data from A into the calculator, it's assuming that your graph is linear. So because you have points way down here and way up here and way over here, it doesn't fit linear. That's why it's your 0.006, because it's really, really not a good graph. And the closer you are to 0, the less linear it is. So that's why it's 0.006. Roller coasters get all their speed by dropping down a steep initial incline. So it makes sense that the height of that drop might be related to the speed of the roller coaster. Here's a scatter plot of the top speed and the largest drops for 75 roller coasters around the world. So, is it appropriate to calculate correlation here? Well, there's two requirements. Is the data quantitative? Drop is measured in feet, that's quantitative, and speed is measured in miles per hour. It is also quantitative. That's great. And then the other question is the data straight enough? Well, I see a good long straight line there. I see a couple of stragglers over here, but yes, that is definitely linear. So we would say that yes, it is appropriate because the data is straight enough and, whoops, let me put it back on pin, and it is quantitative. So, in fact, the correlation of speed and drop this is the correlation for this graph, 0.91. So based on that number, we're going to describe the association. So the direction, that number is positive, which means the direction is positive. We already know it's linear because we discussed that in order to use correlation. And most importantly, the strength. 0.91 is in that top range, so this is a strong graph. So it is positive, we already knew it was linear, and it is strong. Let's look at another example. Your economics instructor assigned your class to investigate factors associated with the gross domestic product of nations. Each student examines a different factor, such as life expectancy, literacy rate, etc., for a few countries and reports to the class. Apparently, some of your classmates do not understand statistics very well because you know several of their conclusions are incorrect. Explain the mistake in their statements below. So my very low correlation of negative 0.722 shows that there is almost no association between GDP and infant mortality rate. Well, this number right here, that's not really considered a low number. It's negative. But if we ignore the negative for a second, it's 0.722. It's at the very top of the moderate region. So that is definitely their mistake. They assumed that negative was bad. Okay, a negative correlation doesn't mean that there is no associate, that they do not associate. It means that as one variable goes up, the other variable simply goes down. And their association is moderate. Okay, so the next one. There is a correlation of 0.44 between GDP, gross domestic product, and continent. Well, GDP is a number associated with each nation, but continent, that's like Asia, Africa, Europe. Continents are not quantitative data. That is this person's mistake. There can't be correlation when one of the variables is categorical. So those were the mistakes that were made. So now we got to look at the important thing. So far, all the problems, I've given you the correlation. We now have to learn how to calculate it. So, there is a very lovely formula for finding the correlation coefficient. And that is this big, ugly formula right here. How would you like to use that? I'm guessing you're looking at that thinking you're crazy, Miss Simon. I am not even going to talk about that formula. We will not use it. You don't need to know how to for my class. We're going to use the calculator. So let's talk about the calculator instructions. The first thing you have to do is enter the data into the calculator. Your x values are going to be L1, your y values are going to be L2, and we've done this before, you're going to press the stat button, and then simply press enter to edit, and then put x in L1 and your y values in L2. Now step number 2, I'm going to circle it for a second here. This only has to be done once. This turns on all of the functionality that we need. So to get to this little option thing, you're going to press second catalog, which is the 0 button. So second 0. You're going to use the arrow keys and you're going to scroll down till you see the word diagnostic on. And then you're going to press enter twice and it should say done. Once you've done step 2, you never do it again. So once you've done step 2, then to find the correlation, you press the stat button. You arrow right to the calculate menu. You need option 8. And simply hit enter until it spits out your data. So we're going to look at 2 examples and I'm going to pull up a little video for you to view the graphing calculator. So we're going to be using the graphing calculator to calculate the correlation going all the way back to examples 5 and 6 from the last lesson. Example 5 was the basketball players and example 6 was the ice cream sales. So you'll have to turn back in your packets if you want to follow along. So here's our little video.
So let's take a look at finding correlation using the graphing calculator. So as your instructions said, the first thing we are going to do is we're going to press the stat button and then we're going to hit enter to edit. Now we have data in here. Remember we looked at this before. If you have data and you need to clear it out, you arrow up to highlight the number, then you press the clear button and then enter. So we're looking at example 5, which was the basketball example. So let's quickly type the X data in the first column, 67, 72, 77, 74, and 69. Arrow over to the L2 column, put in the Y values. And there's all of my data. Now, this next thing I'm going to show you, we only have to do one time period on a calculator. After you've done it once, it shows up. So everybody press second, quit. This is again a one-time thing. You want to get to the catalog, and if you see the word down here, it's above the 0. We're going to press second, 0, and then we're going to use the down arrow key. Just press and hold it until you get down to the D's. All right, and we're going to go a little further to diagnostic on. We're going to hit enter. We're going to hit enter a second time. Once you've done this once on your calculator, you never have to do it again. So if you've done it now, you're good to go for all tests. And my calculators that we use in class, this will never be an issue. So now that we've turned the diagnostics on to see our correlation, as the next step of your directions says, we just finished step 2, we're on to step 3. We're going to press stat again. We're going to arrow right to the calculate menu, but we are going to go down to option 8. So you can either press the number 8 or you can arrow down to 8, whichever one you prefer. If you like to use your arrows, great, there you go. Whoops, one too many. There's 8. Hit enter. And again, just keep pressing enter until the information you want appears. Now, this is a whole bunch of stuff. Not all of this is relevant to us right now. Chapter 8, A and B will be relevant to us in Chapter 8. The only thing that is relative to us right now is the very last item in the list, the R. That is the letter that we use for correlation. Now, my general rule of thumb in terms of rounding, I always went 3 decimal places. So your answer for example 5 would be R equals 0.903. So we're going to repeat the exact same process for example 6. So we're going to press stat again. We're going to press enter to edit. I'm going to get rid of both columns, so I'm going to arrow up. I'm going to press clear and enter. Then I'm going to arrow over and up. And again, clear, enter. So we're going to put all of those decimals in this first column. 14.2, 16.4, 11.9, 15.2, 18.5, 22.1, 19.4, 25.1, 23.4, 18.1, 22.6, 17.2. And then we're going to arrow over and we're going to put in those nice 3-digit numbers. 215, 325, 185, 332, 406, 522, 412, 614, 544, 421, 445, and 408. And then, remember, we don't have to do step 2 ever again. So all we have to do is press stat, arrow right, and I'm just going to press the number 8. It's quicker. And just keep pressing enter until it spits out your information. And again, we want that last one. So for example 6, your correlation will be R equals 0.95, and that would round up to an 8, 0.958. Alrighty, so we have a couple more quick examples to look at. So go ahead and turn the page. So a researcher studies children in elementary school and finds a strong positive linear association between height and reading scores. Does this mean that taller children are general better readers? No. We know that height and reading have nothing to do with each other. Okay? It does mean that taller children are better readers. But why is that? It's because height typically comes with older children, and older children are good readers. Now, it doesn't mean that one causes the other. It simply means that they are associated. But they are associated because, again, that height means that they're older, and older kids typically read better. A survey of the world's nations in 2004 shows a strong positive correlation between the percentage of the country using cell phones and life expectancy in years at birth. Does this mean that cell phones are good for your health? Hopefully you're thinking, no, that definitely does not mean that. Okay, typically what that would mean is that the countries where cell phone use is higher, life expectancy just happens to be higher as well. Why do we think that is? Well, typically countries that use cell phones are your higher economic countries, which also means they have better medical care. And better medical care tends to go along with better life expectancy. So that's why you think there's a relationship, but it doesn't mean that there really is. So, number one thing that's important, correlation does not mean causation. There is not a cause and effect relationship here. When we have a strong correlation, we want to explain it by saying that one causes the other. But we simply say they are associated. They are related to each other, but they do not have a cause and effect relationship. Scatter plots and correlation coefficients never prove causation. And that's the end of chapter 7.